Okay, so this week we are still on geometry, and oh yeah, I will need to shift that annotation mode, right? Got to enable the annotation. Okay, yes, just to keep you updated. Yep. For us to do the questions, we don't want everyone to actually participate at one go. So we want volunteers, so one person can do at one time, okay? So since this is actually revision for geometry, um, so long as you know your properties of a square and a rectangle, you should be able to solve this question. So let me see. I think we have quite a few people who volunteered already. Kaiser Wenxian. Okay, I think Kaiser, you are the first one to actually type in, so you get to do the first one, okay? And then Winshen, I'll let you try the second one, okay? So Kaiser, yeah. So while you're doing that, the rest of you, you just want to observe how it's done. Kaiser, you're always using yellow. Yellow we cannot see very clearly. Can you use a darker color, please? Okay, it's a very good idea to actually underline or highlight because that helps you to figure out what you have read and what are the important clues. Okay, so we notice there's a marking on the square, the corner, which is 90 degrees. Okay, and Kaiser is taking 360 to minus 90 degrees, which means the balance angle should be, and she subtracted 244 as well. Okay, so we are going to find that little angle. Yes, 26 is correct, Kaiser. But we need you to write the 26 in. Okay, so Kaiser has actually identified that angle as 26. Okay, and since the rectangle, the corner is 90 degrees, you take 90 and minus 26, you will get the angle we are solving for, BQG. Okay, BQG is, okay, let me get my annotation also. Okay, she's solving for this little angle here. So this is 64. Okay, good job. All right, because 64 is the smaller angle, then 26 is also another small angle. The two angles add together give you a 90 degrees. All right, well done, Kaiser. Okay, since we have no problem with this, we can move on to question 2. And just now, Wenxian actually asked to try. So yeah, maybe you can try this one, Wenxian. Are you with us? Okay, so Wenchen has underlined, yes, those are important bits of information. Angle BCT is 37 degrees. Okay, that one is already marked in the diagram. Angle DCP is equal to angle MCD. Okay, so angle MCP is equal to angle VCT. Yes, which is the corner of the rectangle actually. Yes, it's 90 degrees. That's correct. Okay, so angle PCD is equal to angle DCM. Yes, that is 45 degrees because it's actually the right angle that has been cut equally into two. So it is 45 degrees. So angle MCB. Okay. Angle MCB is also 45 degrees. Angle W will be angle VCT, which is 90, minus angle MCB, and minus angle, okay, that one I cannot read already, BCT, okay, BCT, the 37. Okay, and you got 8 degrees. All right. So, okay, you are correct, huh? 8 degrees is correct. Actually, quite easy, yeah, because we already know that 45 degrees is actually like this, right? Correct? That's 45 degrees. Yeah. And so the other thing is we have this angle 37 degrees as well. This is 37. Okay. And why is this 37? Because the square overlaps the rectangle on the left. So the part that is overlap for the square and the rectangle is actually this part. Yeah. So because this part is overlap, right? And then you know the corner of the square and the corner of the rectangle both are 90 degrees. So if this one is 37, this side is automatically 37 as well. Yeah. Then we also know that this is 45. You can take 45 and minus 37, you will get your 8 degrees. Okay. So that is question 2. Well done. Okay, let's move on to our next question then, question 3. Okay, the diagram is quite messy actually. Yeah, but the question is not difficult. So the thing is, if we, so long as we are able to see the shapes clearly, we should be able to do the question. So do I have any volunteers for this? Anyone? I'm looking at the chat and nobody is asking to do already. Anyone would like to try? Okay, somebody has typed into the chat. Let me see. Hannah. Okay, Hannah, yeah, you take over for question 3. Let's see. Okay, we have to find two angles. One is I, one is P. P is the big one on the outside at the bottom. I is on the left. Okay, Hannah is taking 90 degrees minus 74. Okay, so this is the corner of the rectangle, right? Okay, yeah, the corner of the rectangle, then you minus 74. Yes. Okay, good job. And so you will get 16 degrees, the little angle that was being marked. Yep. And then now we look at the other rectangle, which is CMRQ. Okay. This other rectangle, the corner is also 90 degrees. So one part of it is 16. So you take 90 minus 16, you get 74. Okay, well done. Okay. So angle I is 74. All right, good job. That's correct. Okay, so now we move on to B. Angle LHJ. Okay, angle LHJ is 180 minus 118. Okay, that is correct. For those of you who are wondering where that is, let me just quickly mark it out. This is the one. Okay, and because the question tells us it is parallel lines, huh? Okay, this is a pair of parallel lines. So you have 62. Well done. Okay, so this is 62. Then she goes on into angle P equals to 360 degrees minus 87 and minus 62. Yes, okay, of course. All right, so this one wasn't mentioned. This one should be 62 as well because it's alternate angles, huh? Okay, you will see the Z over there actually. So this is the Z. Okay, well done. So you get 211 degrees, and that is correct. Okay, wow. So far, so good, huh? 3 different people, everybody knows how to do. Okay, well done. Okay, all right, then let's move on to our next question. So question 3 is not a problem. Let's take a look at question 4 then. Let me just clean this. Okay, do we have a volunteer? Let me see. I think it's back to Kaiser, right? Yeah, Kaiser has typed in. Yeah, okay. Kaiser, you can continue with this question. Question 4. So question 4, we do see a lot of markings. So the markings tell you the lengths are the same. Therefore, we do have isosceles triangles here. Okay, so Kaiser is identifying the pieces of information, PQR being a triangle, and then all the points V, W, and X are points on the triangle. Okay, and then the lines that have the equal length, PV equals to PW, that is the one with one marking. Then VR equals to VX, XR equals to VR. That one it has two markings. Okay, those two lines are the same. Okay, and we are supposed to solve for angle WQX. That's the angle at the bottom. Okay, the angle that's right at the bottom. Maybe I can just color this little angle there. Okay, Kaiser has started doing, let's see. 180 degrees minus 102. Okay, so you look at where 102 is. 102 is actually for two angles, right? And then it is actually on a straight line. Yes. So you get 78 for the other side. That's correct. So once you found the 78, right? 78 turns out to be part of the isosceles triangle, RVX. Therefore, you have 78 and you have another 78, both of them. Okay, so 78 times 2 is 156. Therefore, Kaiser is now solving for the third angle of the isosceles triangle. That's the one at point R. Okay, so 180 minus 156, and she gets 24. That is correct. Okay, let's see how it's continue. Okay, Kaiser wants to identify the angle at the bottom because it's on a straight line, right? So one side is 78, therefore the other side 102 degrees. (180 minus 125). Okay, so now look for the 125. That is the angle that is marked with two lines. So that one is also on a straight line. Yeah. So when you take 180 minus 125, you get the third angle, which is 55 degrees. And 55 degrees happens to be one of the angles in an isosceles triangle as well. Yes. So there are actually two angles